Hello, my name is Jake Haubert, and this is my MECHE 2900 prototype. This is going to be a meat dry aging safety monitoring device. So let me get right into it. This right here is a mock mini fridge. This is what is going to be doing the dry aging. Right now it's just a cardboard box, but what I'm looking to have it run on is just any commercial mini fridge that you can get for about 60 bucks or 20 bucks even used. Right on top is going to be the brains of the machine that houses the Arduino, breadboard, and all other components that I'll get into later in this video. First thing I wanted to point out is this is running off of a wall outlet. What that enables is to have a constant power supply to the Arduino throughout the aging process. The aging process takes around 33 days. However, you can go longer than that, and I didn't want this to be running on a battery as that might die and endanger the safety of the meat. So I'm having it run off of a wall outlet, which is optimal as well since the refrigerator will be running off of a wall outlet too. First thing I wanted to showcase is going to be the LCD display. What this does is displays the temperature and relative humidity in real time. This will enable the user to make sure that everything is being met within the dry aging conditions. Right now the temperature is at 20 degrees Celsius and the humidity is at 42% relative humidity. One thing you may have noticed is this blinking red light. This is an RGB, and what is happening right now is that it is warning the user about a temperature potential failure. Right now the temperature is at 20 degrees Celsius. What we want the temperature to be in is 0 and 3 degrees Celsius. So this is going to endanger the safety of the meat. This will be blinking for about 10 hours. After that, it will be pulsing with a sound emanating from the box as well to let the user know that something is wrong. If the temperature is above 3 degrees Celsius for more than a day, however, the LCD will display temperature fail and the RGB will be a constant red value and it'll be stuck in a while loop. The other thing that can display on the LCD is going to be a humidity fail. What that is after 4 days of the relative humidity being above 85%, it will display humidity fail. Along with that, there will be a blinking blue light as well to let the user know that the humidity is the problem and not the temperature. Both can be a problem at the same time, and this will blink red and blue. Another thing that the RGB can do is once the 33 days has elapsed, that RGB will turn a constant red color. Now, after that 33 days, this will still be monitored and errors will still be able to be shown on the RGB. However, that constant green value will be showcased just to let the user know that the 33 days has elapsed and they're able to cook their meat. So I want to get inside of the mini fridge and showcase what is happening in there. There is going to be a servo motor here that is keeping the door shut as to make sure that the dry aging process is happening uninterrupted. What to do there is to reach into the side here and press a button. When you hold down the button, that servo is put to the side. Once you let go, the servo goes back to its normal position. Inside of the mini fridge is going to be the humidity and temperature probe. This is what is reading, this is what the Arduino is reading and displaying on the LCD above. That will enable the dry aging process to happen safely and within the user's knowledge. Up top is going to be a DC motor. Is running at a low RPM right now. The optimal airflow over the meat's surface is going to be 0.2 to 5 meters per second. That allows optimum aging and drying. So right now, the motor is at a lower speed. However, once the humidity increases, especially in the danger zone, that fan will be running at full speed to make sure that the humidity is lowered. At the bottom of the mini fridge in the dry aging process is typically going to be a lot of salt that takes the humidity out of the air and allows the meat to dry. So let me close that and let's get a look inside of the brains of the machine. In here is going to be the Arduino, which is running the code and giving that to the breadboard here. Additionally, there is a mini breadboard that the LCD is running off of, and here is going to be an active buzzer. That is what is going to sound when either the meat fails or the 33 days has passed. This is the RGB source, and that is the button for the door. Along with that is going to be a potentiometer that the LCD is running off of, the shift register as well, and this is a real-time clock module that is able to accurately keep time throughout the dry aging process. One good thing about the real-time clock module is that the millis function on Arduino is limited to roughly 47 days, I believe it was. This can go further than that, and that is good, especially because people have been known to dry age their beef for more than 30 days. People have gone 60, 90 to even 120 days. Gives different flavor profiles, but that enables for longer dry aging if the user so desires it. So that is the inside of the machine, and that is my MECHE 2900 prototype. Thank you.